I'm Doug Ranalli, founder of NetNumber, here at the IoT M2M Conference in London. Today I'm going to be talking about mobile operators and how they need to evolve their signaling network to support an explosion of IoT devices. So I appreciated the discussions earlier today because they focused so much on end user experiences. What are service providers trying to deliver in the market today with IoT? I'm going to break that trend. I'm not going to talk at all about end user experience. I'm going to talk about some really messy complexity that sits behind the scenes in service provider networks that happens to be impacted significantly by IoT and other trends that we see in the industry today. I'm going to try that again. So before I jump in, NetNumber is a company. We build signaling control technology. I'll tell you what I mean by that in a couple of slides. Today we've heard presentations from Deutsche Telekom, Vodafone, Tele2, TeliaSonera, soon today BT. Those are all examples of customers that utilize technology that NetNumber delivers. We deliver a platform called Titan. It's a general purpose signaling control platform, widely deployed across the industry today. We're lucky that we get to do business in retail mobile operators, fixed line providers, interconnect providers, OTT players, and cable MSOs. So we get a nice view of everything that's happening in the industry. Today we're going to focus specifically on retail mobile operators. So we're here today talking about IoT, but really there are multiple trends that are happening in our industry today that all interleaf. NFV, SDN, IoT itself, 5G, mobile edge computing. Beyond being an opportunity for all of us to spend literally every week going to a different conference, they all represent interesting points of change in our networks that fit together. NFV SDN. It's a multi-decade transformation of our networks. We're going to stop deploying boxes. Instead, our networks are going to be entirely software driven. The boxes just become an infrastructure that exists, and we layer software on top of it. IoT, transformation of our networks from delivering services to my teenage daughters who send an enormous number of texts and stream an infinite amount of video. We're transforming those networks to be connection of literally every device on the planet. 5G, changes to the radio access network to enable this IoT innovation or evolution and allow it to happen in parallel with constant growth in subscriber bandwidth demand. And finally, mobile edge computing. If we move services to the edge of the network that are mission critical and time sensitive, autonomous driving vehicles, and you expect these vehicles to communicate with each other, traveling at 70 miles an hour, latency becomes a really big deal. So if we need a network that delivers services with very low latency, we're going to make changes to the radio access network But we're also going to make changes to everything that sits behind the scenes. The actual functionality of the network is going to have to be moved to the edge. What's the benefit of having a radio access network with a 1 millisecond latency? If you're going to access a service in the core of the network that requires 20 millisecond round trip time to reach, makes no sense. So you know we're going to move technology out to the edge. How do these trends affect signaling control? Well, first of all, let's take a look at what is signaling control. So first, one way to think of it is signaling control is a whole bunch of protocols. SS7, C7 started the concept of signaling control 40 years ago. A separation of the media in our networks, like the streaming of that Netflix video, happens on the media plane. There's a whole separate network that sits above it that controls what happens in the media plane, and that is the signaling control network. It started with SS7, C7. We turned that network into an IP-based infrastructure called SIGTRAN. When we introduced the LTE network and Wi-Fi access, we introduced diameter and radius. As we're all now introducing voice over LTE network and enum, we've always had DNS, and soon you'll see a lot more HTTP as we seek to turn our communications networks into services that can be consumed by developers. We're going to have to talk the language of developers. Developers, they don't know SS7, C7. They do know HTTP. So that's one way of thinking of signaling control. The other is it provides routing functions and it provides database functions. All of these acronyms represent services that exist in every retail mobile operator in the world today. The STP routes SS7 messages. Diameter signaling controller routes diameter messages. These call state control functions, border gateway control functions, they route SIP messages. Signaling firewall protects all of them. So signaling control routes messages, and it answers questions. The HSS HLR, they answer a question, what services have you signed up for? The AUC and Subscriber Data Management Database answer questions like, do I know this endpoint? Is it allowed to connect to the network? Now, what does this all look like in an architecture? What it looks like is something really complicated. In the upper right is the original signaling control network, the SS7 network. It was reasonably manageable. When we introduced LTE, we introduced an entire set of services, additional signaling control services, based on the diameter protocol, but we didn't get to turn down SS7. Now, as we introduce voice over LTE, we add a whole nother set of signaling control services, effectively called the IMS core. Believe it or not, as an industry, we spent 15 years creating this picture. We actually worked hard at achieving this. Now, in truth, as we move our networks to an IoT infrastructure, this doesn't make any sense. Doesn't make any sense, meaning it's too expensive to run a network like this. and it's too hard to scale. So although the functionality has to exist, we weren't stupid. When we created all those blue boxes, we did it for a reason. We need them. So we can't just eliminate them. But we are going to have to figure out how to simplify it. So where we're at today, 19 silo services, all those blue boxes, very slow to evolve. I mean, imagine if someone in your marketing department comes up with a good idea and you need to make a change to your signaling network. What if that change touches 3 or 4 of these boxes, which you know it's going to? If you treat these all as separate silos, how do you ever do that? How do you get the vendors to align their roadmaps and make that change? Truth is, you don't. So that's one reason why service providers tend to be slow to innovate. It just costs too much money and takes too much time to try things out. We need to do better than that. And it's costly to operate. If every one of those 19 functions has to have its own RFP, select your vendor, manage your vendor, deploy the technology, integrate the platform with network management, scale the platform, upgrade the platform, you end up with an army of people trying to maintain the complexity. Signaling, I make my living off signaling control, so I think it's great. I just don't think it should be so complicated. And we need to figure out how to drive cost out of it. So how does NetNumber think about it? At a high level, we think of it as one problem: signaling control. You know, you've got end user, we got end devices in the network. They come in through various network infrastructures, or they come in through the internet. And so we manage lots of complexity at the edge of the network. Typically refer to that as the evolved packet core today. We connect traffic out to the PSTN network. We connect traffic out to other IP-based networks. We connect out to the internet. We bill things. And users sign up for applications. Everything in between is really just one problem: signaling control. And if you think of it as one problem, it's a lot easier to run this network than it is to run that. So we're looking for a mindset change. As a company, we built a platform called Titan. You could think of Titan as the smartphone of signaling control. You know, what we all like about our smartphone: if you want a new application, you just download it. You don't have to carry around 19 smartphones. You don't have to get a new one just because you want it to do a new function. That would be really stupid. That is our history in running our networks. Instead of having one smartphone, like a Titan, we buy 19 of them and then scale them. We said, no, stop doing that. One platform called Titan, and all those 19 functions, they're just apps. Just download the app. Now, a couple of high-level trends. With all these conferences that we go to, my job is to try and distill out how do these trends affect our particular area of technology, and how do we translate that into competitive advantage for our customers? So trends I see: simplicity and scalability. If we're going to keep going down the IoT path, we just have to drive cost and complexity out of the network. Every device isn't going to pay €40 a month to be connected to the network. So we just have to scale differently, and we have to change the cost structure of what we do. Secondly, we're going to move things out to the edge. So if you're going to move things out to the edge, you also need to simplify how you do it. It goes with my theory of, don't think of signal and control as 19 discrete problems. Think of it as one problem. It's a lot easier to distribute to the edge if you think of it as one problem. And finally, I see a huge trend in security. I think one of the biggest areas of growth that we'll see in the signaling core in the next couple of years is operators will deploy technology to protect those signaling networks, protect people from getting access to your subscriber profile, protect hackers from taking over control of your smartphone on the network. There's been a whole bunch of interesting exposés delivered by the press recently, showing examples of hackers taking control of a user's communication services. That's possible today because when we built the signaling control network, the assumption was it's only used by trusted entities. Deutsche Telekom can trust Vodafone. Turns out that's probably true. Deutsche Telekom can trust Vodafone. But what's changed is Vodafone, not picking on Vodafone, probably works with a lot of other companies today that need access to its network. And so, in truth, Deutsche Telekom is no longer just trusting Vodafone. They actually have to trust all of those extended relationships that have access to the Vodafone network. That's creating security breaches in our networks. We're going to have to keep investing in that. So, in IoT, when you look at the standardized IoT architecture for signaling control, we all talked today about lots of different radio access points, including LoRa or LoRa and Sigfox, lots of ways of getting access to the network. But then once you're in the network, here's 6 blue boxes that have been defined as signaling control points for IoT. So once again, we have a point in time in our networks. Are we really going to build each of those as standalone functions? Try to scale them? Manage the software upgrade process? Or are we going to think of it as one problem and you just load the apps that you want? We're hoping we can move the industry to this one platform model. Okay, signaling control moves to the edge. One of the advantages of signaling control is you get one place to manage data. So for example, a user signs up for a new service. Practically, you do need one spot in the network to go update that profile. But in terms of using that profile, it's got to be widely distributed across the network. You can't backhaul all of the questions. What did this guy sign up for? What did Mark sign up for? If we backhaul everything, we introduce slow behavior, which goes against what we're trying to do with IoT. And it creates cost. You actually have to backhaul all the traffic. So the mobile edge computing is about distribute the evolved packet core, distribute applications that are time sensitive. What you also have to distribute is the signaling control that supports those two investments. Security and analytics. Traffic comes in from the evolved packet core and it's looking for signaling control. We're going to see firewalls, but they're specialized firewalls. They are firewalls that operate at a much higher level in the protocol stack than what we experience with IP-based firewalls today. So IP-based firewalls continue to exist. What we're talking about are additional layers of firewall security that have to be application aware. Those are getting introduced in the signaling control layer, protecting all the different protocols that we use: SIP, SS7, diameter, HTTP, radius. One of the outcomes of that process, we capture a lot of interesting information in real time. What's happening in the network? In order to benefit from that, you need some way of analyzing it. So I look at it from my perspective as a technology builder. We build this Titan platform that does this signaling control, sits out in the network, and it's processing messages at a fantastic rate, 100,000 transactions a second, 300,000 transactions a second. Every one of those transactions can produce a summary record that could be used to understand exactly what's happening in the network. But what we see out of our customers is they don't take advantage of it. They don't take advantage of it because they haven't made a big enough investment in analytics. We'd love to see this change. We'd love to be able to take that Titan platform and stream those transaction detail records to an analytics engine. So in real time, carriers can see everything that's happening in their network. What we don't see, though, is carriers so far being willing to invest enough there. They have the skills. If you look into their IT departments, there's quite a bit of knowledge about how to do this. What seems to be lacking is the willingness to think of analytics as one problem that gets fed from many sources. Interestingly, as a vendor, we get asked to bring our own reporting functionality to the Titan platform. Typically, the request is, I want you to give me this reporting capability, but I don't want to pay anything for it. I just think of it as some basic function that I need for free. I think that's a mistake. I think that's way underestimating the power of this real-time data by dumbing it down to some free reports. So I'd love to see, this is my sales pitch for, we don't sell an analytics platform. I'd love to see carriers start to invest more in this. Couple of key takeaway messages. Change is driven by these industry trends. Signaling control is going to migrate all to software. Those 19 functions today, they're all hardware. You can go look at them. You can find your physical STP boxes, your HLR boxes, your diameter signaling control boxes. All those boxes are going to go away. Now it's going to take 10 years. Rational reason, you own the boxes, so you don't want to throw them out. You have to stretch that investment as long as you can. But every investment that's being made today should definitely be made as a software investment. We need to stop shipping boxes. Signaling control will move to the edge of the network. We talked about this. If you need low latency, you can't backhaul to the core of the network. And finally, signaling security is going to become a big deal, and it's going to get bigger. With any luck, industry's been working hard on this. I know the GSMA has been doing a great job in their fraud and security working group, trying to bring together the GSM community to understand this issue and make investments to deal with it. I think that work is going to bear fruit for everybody.